So this lesson is completely the same as in Algebra 2. And there's nothing really that's new being introduced here. Combinations of functions will include add, subtract, multiply, divide, and then the one combination which is not completely intuitive is composition of functions, when you take a function of a function. That one's not the same. The rest of them are things that if you had to guess, you'd guess how to do them without ever being told. So we'll do the add, subtract, multiply, divide, then we will take compositions, and then we'll do a word problem. So the first four are called arithmetic, right? Because they're just arithmetic. Add, subtract, multiply, divide. Right. Now, the only thing that's a little different that you just have to make sure is that the notation. Like when you see the f plus g in parentheses, and then there's parentheses x, that means f of x plus g of x. It's just another way to write the same thing. So if you want, you could write it as f of x plus g of x. Meaning that this, what you see going on here, right, in between the parentheses, which is f plus g, and the parentheses, which has x, is not a multiply. It's the function notation. It's just, they stay together. It means of x, f plus g of x. But f plus g of x is f of x plus g of x. Now, if our two functions are defined above, right, f of x is 2x minus 3, g of x equals x squared minus 1, substitute. Right, just straightforward substitute for both. Right, this is going to go here. This is going to go here. 2x minus 3 plus x squared minus 1. And you should simplify. X squared plus 2x minus 4. So the f minus g, same thing, right? Write it as f of x minus g of x. And then substitute for the f of x and the g of x. Make sure, because we've got two terms in g of x, both of them are being subtracted. Both of their signs will be opposite. So whether or not you take like one step and put a parentheses in front of x squared minus 1, and then distribute the minus, or you just write it right away as minus x squared plus 1. But that 1 does flip sign because it's coming after a subtract. Okay, now simplify. That's negative x squared plus 2x minus 2. Right, the next is a multiply, using just a little dot to mean multiply. And that means f of x times g of x. Substitute. 2x minus 3 times x squared minus 1. Simplify. 2x to the third minus 3x squared plus 2x plus 4. I foiled them. I foiled them and made sure to do it in standard form, highest power term on the left. Yes. What? Should be minus. Thank you. Is the rest of it okay? 2x to the third minus 3x squared minus 2x. Well, that's plus 3. I got that all wrong. Okay. I mean, fairly straightforward, right? The next one, f divided by g of x, a little bit trickier, right? Because you're always going to get that question with the question about domain. It's not going to just say, what's f over g of x? It's going to say, and state the domain. And in this problem, if I do the f over g of x, then it's f of x over g of x, which is 2x minus 3 over x squared minus 1. And you can't simplify it, but you still have to say what's the domain. You know, don't try to divide the numerator by denominator or anything. I mean, if there was a common factor, okay. But the rest of it, most of the time, students get these problems that can't be simplified, and they sit there staring at it thinking, what am I supposed to do to simplify when there's nothing to simplify? Again, what values of x do I have to exclude from the domain because they would lead to a divide by 0? Plus or minus 1, right? The zeros of the denominator are 1, negative 1. And you could figure that out either by just set that equal and solve. I mean, it's factorable, right? It's x plus 1 times x minus 1. So there you'd get it that way. But the zeros of the denominator are not in the domain. So we have to say for the domain, x does not equal plus or minus 1. It implies it equals everything else, but it doesn't equal those. Right? Sometimes they may say all real numbers except, but that's a sufficient way to write it. X does not equal plus or minus 1. Let's see. You okay, Reva? So let's do another one where we got to divide, since that's the main challenge. Out of those first 4, this is probably the most difficult part of it. So we're going to do f over g of x and g over f of x and state domains. So f of x over g of x. So that's f of x over g of x. I wouldn't try to simplify it. Now we got to state the domain. And there's 2 things going on here. And that is, we can't take the square root of a negative number. So that's going to restrict our domain. And we cannot divide by 0. And you can't take the square in the numerator, right? We have to make sure that x for the numerator, x minus 3 is greater than or equal to 0, so x is greater than or equal to 3. Right? Just looking at that square root. For the denominator, um, 16 minus x squared has to be not greater than or equal to 0, because it actually cannot equal 0, because then you'd be dividing by 0. It just has to be greater than 0. And if you solve that, 16 is greater than x squared. So what does that tell you? What does x have to be? Say again? it's got to be between 4 and -4, right? Because you're squaring it. If it's let's say less than -4, let's say -5, when you square it, it'll be greater than 16. So actually, what this describes right here is in between -4 and 4, right? It's open circle, shading in between. So we would have to say, we've already set up here, x has to be greater than or equal to 3. That's to satisfy this one, right? That would start us right here at 3. And so this one here is telling us it starts at 3 and it goes to the right. This one here is telling us that it's in between -4 and 4, right, where I've shaded. So what is the final domain of this thing? No. Can it be between -4 and 3? No. If it's between -4 and 3, then you're taking the square root of a negative number here. So it actually has to satisfy both of those. It has to be between -4 and 4 and to the right of 3, which means it's 3 is less than or equal to x less than 4. Just these numbers right here. Okay, if we switch the division, right, g of x over f of x, what's going to change? Now we've got the square root of 16 minus x squared over the square root of x minus 3. Okay, remember, here we said x had to be greater than or equal to 3 because that was in the numerator. Now we have to say for this piece right here, x minus 3 has to be greater than 0, not greater than or equal to. So x is greater than 3. And here we said the 16 minus x squared was greater than 0 because we didn't want to divide by 0. Here we don't have that problem, right? It's not because they're not dividing by this. So it actually will be this x squared is less than or equal to 16. So from this one here, the top one, we would be looking at a number line anywhere between -4 and 4 inclusive, shaded. And from this one here, we would put on our 3, and this time it would be open circle and shaded to the right. So the only thing different between our domain in the first one and in the second one is the or equal to part of it. Right? Now this domain is 3 is less than x is less than or equal to 4. You all right? Right, which leads us to composition of functions, which is the one that is, not just like you probably would have assumed it was anyway. The composition of functions has this notation, right? F little open circle g in parentheses of x, right? Not to be confused with a multiplication, right? We use the multiplication, the dot, to represent a multiplication, right? Don't look at that and try to do a multiplication because it's going to be completely, missing the intent of the problem. Right? The little open circle is composition. Most of the time, if it's written with the little open circle, we rewrite it like this: f of g of x, right? F parentheses g parentheses x, which you would read as f of g of x. Right? Whether you wrote it like this or you wrote it like that, that's what you're going to read. So normally I would go like this. I would say to myself that this g of x is the inner function. Right? The f of x is the outer function. So when I find f of g of x, the first step is replace the inner function with what it equals. Right? G of x equals that. Right? So we're going to say this is f of 4x squared plus 1. What's that? Well, we're not done yet. We're not done yet. Okay, so first step, I'm replacing the inner function. Second step, you're going to do what the outer function, you have to evaluate the outer function, right? I mean, if I find, generally when I've got a function to find, if I say find f of 2, that means replace the x with a 2. Remember when we did the difference quotient? Find f of x plus h. Replace the x with an x plus h. In this case, we're replacing this x with 4x squared plus 1. It's like, and I've seen students do this, that they seem to have a little more ease. Just take this thing and put it there. Right? So that'll be 2 times 4x squared plus 1 plus 5. Right? Simplify. 8x squared plus 2 plus 5. 8x squared plus 7. Good? You good? Allie? Okay, now, same two functions. We're going to reverse the order. Instead of f of g, we'll do g of f. Right? G of f of x. Again, g of f of x. First step, replace the inner function with what it equals. G of 2x plus 5. Now evaluate the outer function, which means you're going to take this and you're going to put it in the place there. So that'll be 4 times 2x plus 5 squared plus 1. Simplify. 4 times 4x squared plus 20x plus 25 plus 1. Just FOIL 2x plus 5, yeah.
Why did you not put 4x?
What do you mean? 4, this is like the x, 4x squared. 4x squared. In place of the x, I put 2x plus 5. So that's 4, this thing squared plus 1. Does it, you see? It's there. Maybe this doesn't look like a 4. Right? Let me, okay, that is 16x squared plus 80x plus 100, which is 16x squared plus 80x plus 101. So the first slide we did f of g of x, and on this slide we did g of f of x. Were they the same thing? They were. What was f of g of x? Right. So that would be a no. So it tells you the order that you do it matters. It's not necessarily the same, although we will see that sometimes it is, right? But not always. Okay, now same functions, right? And I've already done the f of g of x, so it's 8x squared plus 7. Right? If you have to find f of g of a number, not the squared, right? F of g of 2 would be, since this is f of g of x, that means just put a 2 in the place of x here and here. 8 times 2 squared plus 7, which is 39. But you could also go like this, right? You could write it like, if I write this like f of g of 2, then I can come up here and calculate g of 2. Let's find, what is g of 2? 4 times 2 squared plus 1, which is 17. Okay, so now we're going to take f of 17. Right? But we have the f function right there. So if that's f of x, then find f of 17. Right, so notice that 2 was in the domain of g. And when we put it in the domain of g, we got something which was in the range of g, 17. And then we plugged it in to the domain of f. Right? So the inner function's range becomes the domain of the outer function. I think it depends on the book you had or who was teaching it in Algebra 2. A lot of the practice problems they had for doing compositions were all about like find f of g of 2, right? Which meant you could actually have done the whole thing without actually having found f of g of x. All you had to do was just plug it into f, get the output, put that into g, get the output, done. And you never had to find f of g of x, which we really need to have more practice of actually finding the f of g of x, not just getting numbers for it. So, okay. So when you talk about the domains of the composition of functions, when we do this operation here, we're going to come up with a function, and we're going to look at that function and try to evaluate the domain just based on no divides by zeros, no square roots of negatives, basically just that right now. But we also have to consider the domains of the inner function, because you would never get started in your composition if it violated the domain of the inner function. So when you find domains of compositions, you're going to have to find the domain of the composition and then take into account the domain of the inner function. I mean, watch what happens in this one. Well, what would you say is the domain of the inner function here? F of x is the inner. G of f of x is, so f of x is the inner function. What is the domain of the square root of x? The domain is x is greater than or equal to 0. You're allowed to take square roots of positives. You're allowed to take square roots of 0. Okay, so that's this right here. Okay, now let's do our composition. Let's replace the f of x with the square root of x. And then we're going to evaluate the g function, right? We're going to plug in the place of the x here, we're going to put the square root of x. So we have to say the square root of x squared plus 4. Well, what do you got when you square the square root? You just get the x plus 4, which is linear, right? If you were asked if a function equals x plus 4, what's the domain? You would say all real numbers, right? But it's not, because this is the composition, and the inner function had a domain which was x greater than or equal to 2. So the domain of the composition cannot be more inclusive than the domain of the inner function. So we have to say the domain of the whole composition is x is greater than or equal to 0. Okay, we definitely look at that and say, you know, is there anything there? Is there any divide by zeros, any square roots of negatives? And there isn't. But then we take that into account. So the domain for the composition is linear, which would make it appear like it's all reals for the domain. But this domain of inner function is the domain of the composition. You know, if you did it the other way around, right? What if we did g of f of x? Then you would have, no, that's what we did. What do you found f of g of x? F of g of x would have looked like this. It would have been the square root of x squared plus 4. Now, you're looking at that as the domain of x is greater than or equal to 0. But looking at that composition, is there anything that you can't plug in for x? I mean, this is always positive. X squared plus 4 is always positive. So the domain of the composition is all real numbers, right? The domain of the inner function, x squared plus 4, is all real numbers. The square root's not going to change that, so it's always positive. You have to, I can't say every one is going to be the domain of the inner function, that's it. You just have to take it into consideration, right? Take it into consideration. Last problem. This is the example 8. Right? So obviously it's going to be about compositions of functions. The number n of bacteria in refrigerated food is given by this equation. Capital N of capital T equals, and it's a quadratic. And at the end it says 2 is less than or equal to T is less than or equal to 14. What does that represent? It's the domain, right? They're telling us what values can you plug in. Not because actually if we plugged in different values, it would lead to anything bad. It's just that this is a real life, relationship between temperature and number of bacteria. And it's just not valid if you're less than 2 or more than 14, right? It's good for those temperatures. And the temperatures are in degrees Celsius. Okay, so this is number of bacteria as a function of temperature. Okay, the next is when the food is removed from the refrigerator, it's got a certain temperature, it's probably cooler than it's going to be. Then the temperature of the food is given by another equation. This is the temperature as a function, temperature capital T as a function of time, little t, right? 4t plus 2. And again, it has a domain. Right? This is going to be good for up to 3 hours. Right? So the first part of the problem says, find the composition of the function n of t, right? Where the first t is capital T. N of t. Find the composition. And the second part will be, find the time when the bacteria count reaches 2,000. Well, how do you find the composition again? The n of t, the first step would be replace the inner function, right? Whatever this P of t is, put that in place. That's n of 4t plus 2. And then what are you going to do? In the place of the capital T here, put 4t plus 2. So you're taking this thing right there, and it's going to go here, and here, and then obviously you're going to have to simplify. And I've got that on the next slide. Good, Terry? Okay. This is taken out of the book. Okay, here's what you get when you plug in the 4t plus 2 for the capital T, right? And they did all the work in the problem, and I'll trust their work. So now we've got this n of t equals 320 t squared plus 420 t, right? This is n. This is n. N equals 320 t squared plus 3. Okay, they said find the composition and then interpret it. What is this telling us now? Just describe what kind of a equation this is. It's a function of n, number of bacteria, and what's the independent variable now? Time, right? We started out with a function of number of bacteria is a function of temperature. Now we've got a function which is number of bacteria as a function of time, right? Slightly different thing. So this is actually n of little t. Okay, then the last part is find the time when the bacteria reaches 2000. What are they asking you to do? No. When the number of bacteria reaches 2000, what are you substituting 2000 for? The n, right? They said when the number of bacteria, that's represented by the capital N. So you want to go like 2000 equals 320 t squared plus 420. Subtract 420, 1580 equals t squared. Oops, that's not right. Equals 320 t squared. T squared equals 1580 divided by 320. And then you have to take square root of both sides. Right, so t is the square root of 1580 divided by 320. And I think in the book they did that. It was like 2.2-ish if you do it. Approximately 2.2. Would we have to worry about the plus or minus here when you take the square root? Yeah, time is not going to be negative, right? So this represents 2.2 hours. Remember, that thing was good from 0 to 3, so that's within the domain right there. Okay. So there'll be one of the word problems in the homework is pretty similar to that, right? So you want to base it pretty much on that. The other one, it'll be a little bit different, but try to figure it out. Add, subtract, multiply, divide, compositions. And that's the homework. Again, quiz next time is those 4 sections. Not anything we did today.